Hello everyone, I'm Shamli Sharma. I'm from SAS Institute of Management. Correlation analysis. What exactly it is? Yeah, it's a very important term from your business statistic concept. So let's move what exactly it is and what are the uses of this terminology. What does it mean? It is basically a statistical method which is used for research and development in order to measure the protocols, the linear relationship between variable and computation with their association. When to use? Why to use? Yeah. So when we are dealing with a particular variable, it helps to deal with their linear relationship. It helps you to compete with their bind up and study the represents the response and outcome of particular variable. For example, demand and supply, one of the very often element for which we can imply this concept. Types of correlation: positive, negative, zero correlation, linear or collinear correlation, scatter diagram, as we said that it is a graphical representation, Pearson product movement coefficient of correlations, Postman rank correlation coefficients. As the name differ, the types and the utility also depends. It depends upon the situation when it is carried forward or what kind of outcome is required. It depends upon the utility factor. Here we are having certain diagram, or we can say a graphical structure of the types, that is positive correlation, where we can see the arrow is moving upward in the right direction when there is no relation, that means the relation is not bind up. You can see the dots which are scattered here and there, which doesn't form a linear relation among the variable. There we can say that it is no relation. Okay, the third concept where we can found the dotted or the relation among the variable, they are having a downward slope. Okay, negative pointing towards a slope from left to downwards, where we can say the marking is in minus 0.4. So this is what types and categories and what exactly it means. Yeah, so over here we are having a equation as well as an example which will give you a brief knowledge with regards to how it works. Okay, firstly, the correlation coefficient is denoted by R, and we are having very important, very beautiful example. An agriculture represent organization tested particular chemical fertilizer to try find out whether an increase in amount of fertilizer use will lead to corresponding increase in food of supply. So here we are having certain data which is segregated into x and y variable. X, that is your fertilizer, and y, it is beans. Okay, then we will take a combination of, that is xy and x square y square. Here we will go with computation of formula, that is r, correlation coefficient, and we will put up the formula, and which gives you a count of total number of variable. Then we are having sigma and product of xy, that is subtracted from sigma x sigma y, and a root which is carried forward into a bracket number of a particular range in which there is sigma x square minus sigma x square, and rest which is also similar with the y variable, and through it is the variable have been calculated, they are multiplied and jotted as per the required data, and finally we get our output. This is how the correlation coefficient is calculated and defined. It is very useful as well as essential element in order to come with an outcome. When we are dealing with more than one element, it shows a direct relation as well as. So by this I would like to end up my slide. Thank you.